Hello and welcome everyone. This is Mohammad Izamam from SAIMEDHA ECET Coaching Center Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing a golden opportunity to all the ECET 2024 and as well as ECET 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, SAIMEDHA Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. Ranks గురించి చెప్పాలంటే SAIMEDHA Koti, Hyderabad లో every single time, every single year we have proven that maximum ranks in all the branches ECE, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous ECET examination questions will be explained by expert faculties. My dear students, గుర్తుపెట్టుకోండి, ఓన్లీ ప్రీవియస్ ఇయర్ కాంపిటేటివ్ ఎగ్జామినేషన్ క్వశ్చన్స్ కొరకే సపరేట్ కోర్స్ ఉంటుంది, పే చేయాల్సి ఉంటుంది బయట మార్కెట్లో. కానీ SAIMEDHA Koti, Hyderabad లో ఫ్రీ ఆఫ్ కాస్ట్ we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous ECET examination questions with which you can understand the level of teaching, the expertise which is there in the SAIMEDHA Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the ECET 2024 and ECET 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Now here we are discussing question number 6, 2010 question. For a quarter wave transformer, characteristic impedance is related with input impedance and load impedance. So this is a matching device related question. So when the transmission line is mismatched, then also to transfer maximum signal towards load, we are using matching devices. There are two types of matching devices we are using in transmission line. One is quarter wavelength transmission line and second one is step. So this question is related to quarter wavelength transmission line. So here what is quarter wavelength transmission line means? It is also a small section of transmission line but where length L equal to lambda by 4. What is the length of the transmission line here? L equal to lambda by 4. Now I am calculating the input impedance of this quarter wavelength transmission line by using input impedance formula. What is input impedance formula? Zi is equals to Z0 into Zr plus JZ0 tan beta L, JZ0 tan beta L divided by Z0 plus JZR tan beta L. This is input impedance transmission line formula. You must remember, almost every year one question is asking from this formula. So what is the input impedance formula? Zi is equals to Z0 into Zr plus JZ0 tan beta L divided by Z0 plus JZR tan beta L. Here length of the transmission line is lambda by 4, L equal to lambda by 4 and beta formula in terms of lambda, beta is equals to 2 pi by lambda. L equal to lambda by 4, beta equal to 2 pi by lambda. By using these two, beta and L, beta L equals to, I am writing beta L equals to 2 pi by lambda into what is the L value? Lambda by 4. Lambda cancel, 2 1 ja 2, 2 2 ja 4. So beta L equal to pi by 2 radians. What is the beta L value? Pi by 2 radians, because beta L units radians. Now pi by 2 means what? 90 degrees, tan 90 infinity. What is the value of tan 90? Infinity. So for simplification I am taking common tan beta L in numerator and denominator. Then what happens here? Z0 into tan beta L common, cancel, Zr by tan beta L, Zr by tan beta L plus JZ0 divided by, again tan beta L common, cancel, Z0 by tan beta L plus JZR. So tan beta L value here tan 90 value infinity, something by infinity value it is 0. So input impedance Zi equals to, I am writing Z0 into Z0 square divided by Zr. Zi equals to Z0 square by Zr. From this Z0 square is equals to Zi into Zr, and finally Z0 is equals to under root of Zi into Zr. What is Zi? Input impedance. What is Zr? Load impedance or receiving end impedance. Now this is the question answer. See here, the characteristic impedance. What is the symbol of characteristic impedance? Z0 is related with the input impedance and load impedance. Here input impedance is Zi and load impedance is Zr. Therefore Z0 is equals to under root of Zi into Zr. So that is the answer. In quarter wavelength transmission line, characteristic impedance Z0 equals to under root of Zi into Zr. So in that options E is given input impedance as Zs. So Z0 is equals to under root of Zs into Zr. That is the correct answer. So option 3 is the correct answer. Next question. Question number 7. Phase velocity in a transmission line is not given the type of transmission line. When is not mentioned the type of transmission line, consider the transmission line is lossless. So what is the definition of lossless transmission line? Means a transmission line is said to be lossless when, remember, the conductor of the transmission line is a perfect conductor and the dielectric medium between the two conductors is perfect dielectric. The conductor of the transmission line is a perfect conductor. That means R becomes 0. And the dielectric medium between the two conductors is also a perfect dielectric. That means Z equal to 0. So here R equal to 0 and G equal to 0 is the condition for lossless transmission line. Then is asking what is the phase velocity. See here, phase velocity formula Vp is equals to here omega by beta. What is the phase velocity formula here? Omega by beta. What is omega? Angular frequency. And what is omega units? Radians per second. And beta is what? Phase constant. What is the units of beta? Radians per meter. So omega units are radians per second, and beta units are radians per meter. So radians per second divided by radians per meter means what? Meter per second. Per second is the units of velocity. So here phase velocity Vp equal to formula omega by beta. What is beta here? Phase constant. How you determine beta value here? From propagation constant. Propagation constant formula in transmission line. Gamma is equals to formula under root of R plus j omega L. R plus j omega L into G plus j omega C. G plus j omega C. Constant formula under root of R plus j omega L into G plus j omega C. So the condition for lossless transmission line is what? R equals to 0 and G equals to 0. R equal to 0 and G equal to 0. If R equal to 0 and G equal to 0, then propagation constant gamma becomes as j omega into under root of LC. J omega into under root of LC, because omega becomes omega square, root omega square I am writing omega. This is propagation constant, j omega root LC. What is the units? Per meter. And we know that propagation constant is a complex number and gamma is equals to formula alpha plus j beta. What is propagation constant formula? Gamma equals to alpha plus j beta. What is alpha here? Attenuation constant, and beta is phase constant. From here, if you compare these two formulas, beta is equals to what is the value? Omega into under root of LC. Beta value here omega into under root of LC. But is asking phase velocity. What is the definition just now given? Vp equal to omega by beta. Then Vp phase velocity is equals to omega by beta. That equals to, I am writing beta value omega by omega into under root of LC. In numerator and denominator omega will be cancelled. Then finally phase velocity Vp is equals to 1 by under root of LC. 1 by under root of LC units meter per second. So this is the answer. Vp equals to 1 by under root of LC. Option 4 is the correct answer. This is the definition. Phase velocity equal to omega by beta. Here you consider the transmission line is lossless. What is the condition of lossless transmission line? R equal to 0, G equal to 0. First write propagation constant formula, substitute the condition, then gamma equals to j omega root LC. Compare with the standard definition of propagation constant. What is that one? Gamma equals to alpha plus j beta. By using these two equations, beta is equals to omega into under root of LC. Substitute beta value in this definition, then phase velocity formula is 1 by under root of LC meter per second. Next question, question number 8. Yes, there are 4 different types of cables is mentioned. Transmission line having characteristic impedance. If it is open wire transmission line, if it is short circuited transmission line, if it is a twin led transmission line, if it is coaxial cable transmission line. So out of these 4 transmission line, if it is open wire transmission line, this is. If it is short circuited transmission line means this is the short circuited transmission line. If it is coaxial cable, means this is the coaxial cable. And if it is a twin wire, this is twin wire. So 4 cases is mentioned: open wire, short circuited transmission line, and here coaxial cable, short circuit transmission. Out of these 4, which transmission, all these 4 are transmission line, which transmission line having least characteristic impedance? Least characteristic impedance. The correct answer is here option 1. Option 1 is the correct answer. Next question. Question number 9. This is 2011 question. When a lossless transmission line is terminated in its characteristic impedance. So this is a transmission line having secondary constants Z0 and gamma. Having secondary constant Z0 and gamma. What is Z0? Characteristic impedance, and gamma is propagation constant. If the transmission line is terminated with, terminating means some ZR is there. What is ZR value is mentioned here, one condition, ZR equal to Z0. ZR equal to Z0, that is mentioned in question. When a lossless transmission line is terminated with characteristic impedance, then option 1 it behaves as an inverter, option B its input impedance is 0, option 3 it behaves as an infinite line, option 4 its input impedance is equals to characteristic impedance. So just now explain input impedance definition. What is input impedance formula here? Z input. Z input is equals to Z0 into ZR plus JZ0 tan beta L, JZ0 tan beta L divided by Z0 plus JZR tan beta L, Z0 plus JZR tan beta L. So this is input impedance formula. What is the formula? Z input equals to Z0 into ZR plus JZ0 tan beta L divided by Z0 plus JZR tan beta L. This is input impedance formula. Zi equals to Z0 into Zr plus JZ0 tan beta L by Z0 plus JZR tan beta L. In our question, the transmission line is terminated in its characteristic impedance. That means what? Transmission line load impedance terminated, connected output side with its Z0 value, means Zr is also Z0. So if you consider Zr is also Z0, I am writing here Z0, here also I am writing Z0. Then what happens? Z0 into Z0 plus JZ0 tan beta L divided by Z0 plus JZ0 tan beta L. That means all this bracket term will be cancelled in numerator and denominator. Then input impedance Zi equals to Z0. What is input impedance? Zi equals to Z0. So its input impedance Zi is equals to characteristic impedance. Option 4 is the correct answer. So when the transmission line is terminated with its characteristic impedance, then its input impedance is equals to characteristic impedance. Next question, question number 10. Yes, this is 2012 question. When electromagnetic waves travel in free space only, one of the following can happen: A. Attenuation, B. Reflection, C. Refraction, D. Absorption. So whatever may be medium, when electromagnetic waves travels in free space, compulsory there will be happen what means attenuation. There will be happening is what? There is an attenuation will be existing. To determine that attenuation, we are considering attenuation constant. What is the symbol of attenuation constant? Alpha. To determine attenuation constant as well as phase constant, alpha and beta, we are considering the secondary constant term, propagation constant gamma, where gamma is equals to alpha plus j beta. What is alpha here? Attenuation constant, and beta is phase constant. So when an electromagnetic wave travels, after particular distance it travel, what happens? First attenuation will be existing. This is the question. Next question, question number 11. This is ECET 2012 question. The minimum standing waves occur where reflection coefficient is. Actually, the ideal value of standing wave ratio is what? The ideal value of standing wave ratio is 1. But practically standing wave ratio is always greater than 0. So practically standing wave ratio is greater than 0. The ideal value is 1. When standing wave ratio value becomes 1 means when there is no reflection. When there is no reflection, what is the reflection coefficient value? 0. So here the minimum standing waves occur. The minimum standing waves occur means standing wave ratio value is 1. What is the value of standing wave ratio? 1. The minimum value of standing wave ratio is 1. But what is the maximum value here? Infinity, and the range is 1 to infinity. But here the minimum standing waves question is asking the minimum standing waves occur when the reflection coefficient is. So standing wave ratio becomes 1 when there is no reflection. When there is no reflection means reflection coefficient equal to 0. Because standing wave ratio formula in terms of reflection coefficient is SWR is equals to 1 plus mod k by 1 minus mod k. 1 plus mod k by 1 minus mod k. So to determine reflection coefficient, determine standing wave ratio by using reflection coefficient, here is asking question when reflection coefficient is 0. When reflection coefficient is 0, then what is the standing wave ratio value? 1. This is the minimum standing waves value, standing wave ratio value, that is what? 1. So it will be existing when there is no reflection. That means reflection coefficient is 0. Option 1 is correct. Next question, 12th. Impedance matching over wide frequency range can be obtained by using double stub. There are two matching devices are there. One is quarter wavelength transmission line, second one is stub. Again in stub we are discussing two types of stubs, open circuit stubs, short circuit stub. After that we are discussing single stub, double stub. So the major advantage of double stub is it is used in wide frequency range. So correct answer is option 2. Next question, question number 13. A lossless transmission line will be distortionless if the phase shift. So just now we discussed lossless transmission line. Now a lossless transmission line will be distortionless if the phase shift. So first I am asking the question, what is a distortionless transmission line? A transmission line is said to be distortionless if an attenuation constant is independent of frequency and phase constant is linearly dependent on frequency. So what is the condition of distortionless? Definition of distortionless means if an attenuation constant is independent of frequency and phase constant is linearly dependent on frequency. So here is asking only the question related to phase constant. So phase constant linearly varies with frequency. Linearly varies with frequency. Hence correct answer is what? Option 3 is the correct answer. The same thing, one more question paper is asked question, if an attenuation constant is independent of frequency. So I am considering frequency x-axis, attenuation constant alpha y-axis, it is independent of frequency means what is the graph? Like this. Attenuation constant is independent of frequency and phase constant is linearly dependent on frequency. See here, y-axis beta, x-axis frequency, frequency versus phase constant. When phase constant linearly varies with frequency means the graph is like this. See here. So these are the distortionless characteristics. If attenuation constant is independent of frequency and phase constant is linearly dependent on frequency, then the transmission line is said to be distortionless. Here our question number 13 is asking only one condition, if the phase constant. So a phase constant, if the phase constant changes, varies directly with the frequency, then the transmission line is distortionless. Option 3 is correct answer. Next question, 14th question, this is 2013 question. The characteristic impedance of a lossless transmission line is equals to. So here characteristic impedance formula using primary constants, Z0 is equals to under root of R plus J omega L, R plus J omega L divided by G plus J omega C. R plus J omega L divided by G plus J omega C. This is characteristic impedance formula and what is the units? Ohms. Now is asking characteristic impedance value in a lossless transmission line. So what is the condition of lossless transmission line? The condition of lossless transmission line is R equals to 0 and G equals to 0. The conductor of the transmission line is perfect conductor and the dielectric medium between the two conductors is perfect dielectric. R equal to 0 and G equal to 0. So when R equal to 0 and G equal to 0, then the characteristic impedance Z0 becomes as Z0 is equals to, see here, R0, Z0, J omega cancel, Z0 is equals to under root of L by C ohms. Z0 is equals to under root of L by C ohms. So in our four options, under root of L by C, option 2 is the correct answer. The characteristic impedance of a lossless transmission line is equals to Z0 under root of L by C. Option 2 is correct answer. Next question, question number 15, 2013 question. The standing wave ratio is equal to unity, it implies that. So question is related to standing wave ratio. standing wave ratio is equals to unity. Unity means what? 1. So is asking indirectly when standing wave ratio becomes 1. When standing wave ratio become 1, is asking 4 question is given. When the transmission line is open circuited, when the transmission line is short circuited, when the transmission line characteristic impedance is equals to 0, and when the transmission line characteristic impedance is equals to load impedance. So here we know that the relation between standing wave ratio and reflection coefficient is what? Standing wave ratio SWR is equals to 1 plus mod K by 1 minus mod K. What is K here? Reflection coefficient. Mod means what? Magnitude of reflection coefficient. So this is the relation between standing wave ratio and reflection coefficient. Here is given one condition. Standing wave ratio becomes 1. Yes. When standing wave ratio becomes 1? When K becomes 0. When K becomes 0 means what? When there is no reflection. When there is no reflection, at what condition? When ZR is equals to Z0. When ZR is equals to Z0. What is ZR? Receiving end impedance. What is Z0? Characteristic impedance. So when receiving end impedance or terminating impedance is equals to its characteristic impedance, the transmission line is perfectly matched. When then there is no reflection. When there is no reflection, K becomes 0. When K becomes 0, then standing wave ratio equal to 1. So is asking the condition only. When standing wave ratio is 1. Same thing. What is the answer here? The transmission line characteristic impedance is equals to load impedance. Characteristic impedance means what? Z0. Load impedance is also known as receiving end impedance, ZR or ZL. So when ZR is equals to Z0, when ZR is equals to Z0, then there is no reflection. When there is no reflection, standing wave ratio becomes 1. Hence here option 4 is the correct answer. Question number 15. What is the correct answer? Option 4.
So my dear students, for ECET 2024 and ECET 2025, SAIMEDHA KOTI Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi SAIMEDHA KOTI Hyderabad in this very week, guys. In this very week only, we are providing the maximum concessions. A concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, with materials, without material, online coaching, total మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్ లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద SAIMEDHA KOTI Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous ECET examination questions. I wish you all the best. This is Mohammad Inzamam signing off.